So thank you for joining us in this interesting session. And we are moving forward still in the regular season under trigonometrical functions. And today we are looking at problem number 5 in the MIT 2023 Integration B regular season set of questions. And that's the integral of x cotangent of x from 0 to pi over 2. Now, this problem looks benign, but it's a very complex problem. So quickly, I think what we need to use here is integration by parts. And the way we do that is first of all by expressing x cotangent x as a product of x and the derivative of the natural logarithm of sine x. So the derivative of the natural logarithm of sine x results into cotangent of x. So we have the product of x and the derivative of natural logarithm of sine x. And so when we use integration by parts, we have the product and of x and the integral of that derivative first, and then we subtract um, the integration of the derivative of x and the and log natural logarithm of sine x as shown here. Solving for the limits within this integral, the first term there is the same as pi over 2, natural logarithm of sine of pi over 2 minus this integral, the limit of x log sine x as x tends to 0, since the logarithm of sine x at 0 is logarithm of 0, which is not really defined, but we know where the value of that tends towards. So essentially what this is telling us is that pi over 2 times log of sine pi over 2 is log of 1. Log of 1 is 0, so this initial term is 0. And as x tends to 0 here, this term also tends to 0. So this initial term goes out, and now we are left with the negative of the integration of natural logarithm of sine x from 0 to pi over 2. So this is our function of interest. So since our integral is been reduced to negative of the integral of log of natural logarithm of sine x from 0 to pi over 2, we can now set y to be equal to pi over 2 minus x. That means that dy dx is equal to negative 1, and therefore negative dy is equal to dx. So substituting in for x, if we make x the subject here, we realize x is equal to pi over 2 minus y. So inside the bracket here, we've replaced x with pi over 2, and dx has been replaced with negative dy. And what that leads to is the so sine pi over 2 minus y is the same as cosine y. And in order to eliminate this negative sign, we can just quickly flip the limits here. So since cosine y is symmetrical about 0 and from about 0, so we can easily flip the limits there. So essentially what this means is that the integral of logarithm of sine x from 0 to pi over 2 is the same as the integral of log of cosine x from 0 to pi over. So how we're going to use that is, now since our integral is negative of logarithm of natural logarithm of sine x from 0 to pi over 2, that is the same as half of the integral of 0 to pi over 2 of log sine x dx, sine x, and also plus log of cosine x. Using the properties of logarithms, where we have addition of distinct or different log functions, we can now just multiply whatever is inside the log functions. So that results into negative a half of integral of 0 to pi over 2 of log sine x cosine x. And we can play around with the denominator and the numerator. So we have 2 multiplied to the numerator and 2 to the denominator. So that means that we have negative a half from 0 to pi over 2, the integral of log sine 2x minus, again using properties of logarithm, where you have division within the log functions, you can now separate by subtracting the log of those terms. And so the pi negative a half can be transferred out there. So negative a half times the negative one there, it results into a positive 1 over 2. The integral of 0 to pi over 2 log 2 for the second term. And the first term here, now we are left with the integral of negative a half integral of log of sine 2x from 0 to pi over 2. Now the integral of log of sine 2x from 0 to pi over 2, we can simplify that by saying let u be equal to 2x, so that du dx is 2, and therefore I have du is equals to dx. Now the limits can be transformed. 0 becomes 0 from x to u, and then when x is equals to pi over 2, u becomes pi. And so we have that logarithm of natural logarithm of sine 2x integral is the same as I have the integral of log of sine u from 0 to pi. Okay, so and then again, since we know sine to be symmetrical about u equals to pi over 2, that means that log the this pi over from the limit of 0 to pi can be divided into two subsections. So the integral of log of sine 2x is the same as a half times 2 now, and 2 here represents that we've split the two regions of 0 to pi into 0 to pi over 2, and obviously pi to pi over 2 to pi. So the half and 2 there cancel out. So essentially the integral of log of sine 2x from 0 to pi over 2 is the same as the integral of log of sine u from 0 to pi over 2, which is interesting. Then we go further now to utilize that expression, since we found out that integral of log of sine 2x from 0 to pi over 2 is the same as the integral of log of sine u from 0 to pi over 2. That means that the integral of log of sine 2x is the same as the integral of log of sine x from 0 to pi over 2. Therefore, since we demand to have the integral of the negative of natural logarithm of sine x from 0 to pi over 2, and we found out that that was the same as the integral of logarithm of sine 2x from 0 to pi over 2, half of that, plus half of the constant log 2. We can now substitute for the integral of log of sine 2x with something similar to what is on the left-hand side. And since we can just plug the same value on the left-hand side in place of the integral of log of sine 2x, we can add both sides half of the integral of log of sine x, and so the left-hand side component becomes negative a half, right? and this cancels out. So we have negative a half integral of log sine x 0 pi over 2 equals to the integral of a constant log 2 times a half, and the halves definitely cancel out, and then we can pull out this constant. So essentially, the integral of negative log natural logarithm of sine x is the same as log 2 times the integral of 1. So log 2 times what we see here, which becomes pi over 2 times log 2. So therefore, the integral of x times cotangent x from 0 to pi over 2 is equals to negative the integral of negative of natural logarithm of sine x from 0 to pi over 2, which is equals to pi over 2 times the natural logarithm of 2. And this is the answer here. So a little bit convoluted, but that's the answer we would get for this problem.